Hi, it's Jan Beta, and after the quite devastating, at least for me, last episode, I'm going to try to repair my Amiga 3000T power supply in this one. Yeah, the last episode didn't go exactly as I planned, although I thought I took a lot of attention to all the little details. I managed to replace all the capacitors in this thing, which worked before I did that. And after I did that, it doesn't work anymore. The fan kind of wants to spin up when I power this on, but it doesn't do anything else. No voltage on the outputs, nothing. So yeah, I think I'm going to have to take this out of this enclosure again and do some troubleshooting. I already have some ideas at what to look at, in particular screwed up solder connections. But yeah, we're going to have to take this thing apart again and have a closer look. And just in case I don't get anywhere with this repair attempt, which is, of course, a possibility, I already ordered an adapter to use an ATX power supply, standard PC power supply, as a replacement. But I at least want to give this a shot. As I said, I don't know anything, basically, about power supplies, at least about switching power supplies. Can build you a pretty decent linear power supply, but that's not quite enough to power an Amiga 3000T. The best case scenario is I get this fixed and it's just something that I can fix, which is pretty limited in regards to switch mode power supplies and my skill set. Or we have the other option, which is replacing it with a modern PC power supply and an adapter board. Yeah, I prefer option one, of course, because I like to keep my hardware as original as possible, and this is definitely part of the Amiga 3000T lore, if you will. Worst case scenario is I'm going to have to replace this with a modern power supply, which technically is probably a good idea anyway, because as I've read, these power supplies are not super reliable. Although it seems decent enough, especially regarding the build quality and things like that. But these seem to develop issues pretty frequently, even if you recap them and do all kinds of work on them. Yeah, we are just going to take it fully apart again. Or rather, I'm going to take it fully apart again and hopefully find a fault. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding. They can populate your boards for you, and they can also help you design your boards in the first place. So if you're interested in any of those services, I highly recommend checking out the link in the video description. Back to our Amiga 3000T. So one suspect I found upon looking through my parts bin of removed parts are the large 683 microfarad capacitors. I ripped out the through-hole plating completely. And I noticed when I did this the first time around that I ripped out some of the pads, but I didn't notice the through-hole plating. So maybe you can see the pad still on here, the round thing, and a copper tube, basically, both pins. So yeah, not the best work, but it was really easy to do, it seems. I didn't even notice it. I noticed the ripped pads and checked if there were connections on those, but there aren't on the other side of the board. So the pads on the underside of the board were still intact, but I don't know if one of the pads I didn't rip needs a connection to somewhere from the bottom to the top. So it might be that I broke a connection from the bottom layer of the board. As I said in the first video, this is a dual layer board, so top layer and bottom layer, and both have connections on them. And I think there is a connection on one of these on the top layer of the board that it might not be connected through completely. So I'm probably going to pull these capacitors again, the new ones, and just see if we have a good connection there. Unfortunately, I can't see where the connection is supposed to go, and I could have measured that otherwise, but I'm not able to see with the capacitors in there. So let's remove them again and see if I can see something. And if you are screaming at me for breaking the board, I'm sorry. I was as careful as I could, I guess. But this was really, really easy to break. Okay, got them out again. Ha! And indeed there is a trace going to the other side there. So, yeah, you can see here my ripping of these pads, which are not connected on this side of the board. So we should be fine. They are still connected through the board usually. So there's through-hole plating with copper, as we've seen on the old caps. And this one isn't connected on this side as well. This one isn't. So I ripped these two pads off on this side. And this pad is still there, but I ripped the little copper tube that connects this to the via on the other side of the board. And this goes to here. So yeah, this is supposed to be a connection on this side. And this might just be our whole problem. So yeah, I think what I want to do is to try to put a little wire in there, like a component leg or something, and bridge this to the other side. There may be other disconnects on the other large caps. I haven't checked those yet. This was the first idea that I had. Yeah, that's something like that. Should do. Just bending the wire over here. So I'm just using a wire now. I'm just going to solder that onto the top layer here and stick it through the bottom layer and bend it over and connect it to the capacitor, which obviously needs to go back at some point. That is connected. So we're building our own through-hole plating here, basically. So this should be connected to here. Yep, it is. So let's see if we can get the capacitor in there and have it still be connected to there. And even more importantly, if this actually makes the whole thing work again. Just going to kind of tack them in place. Still holding them down at this point. Should be in there. And yeah, the solder should technically flow through there pretty well with the wire in place. Do we still have a connection now? Yay! So I inspected some of the other solder joints and they do look good. So yeah, not sure if this is going to fix anything, but maybe we should just try. I'm just going to measure some of the more obvious things that I can see that might be broken connections, like similar to what this was. This one is connected on the bottom. Let's see some of the other capacitors here. These are totally connected. It might just have been that one fault. So yeah, maybe worth a try. And I'm going to do something extremely dangerous that I don't recommend you do at home. I'm going to power this on out of its enclosure. So I'm using a ground fault interrupter here, which is going to save me in case something goes horribly wrong and I touch the wrong part. I hope I won't do that. So in theory, if that was indeed the fault, we could have the fan spinning up when I power this on. Okay, that was more fan spin than we got before, I think. Something wants to power up, but not quite. Yeah, basically the same as before, unfortunately. Let's see if we get any voltages on the output. I have my probes stuck into one of the hard disk connectors here. Yeah, no, it just turns off immediately. Yeah, that's not good. I'm just going to go in and check all the solder joints again, I guess. I ripped some more through-hole plating off here on this one. The other ones seem to be alright, I guess. Yeah, I think one of these might also be an issue. If you want to remove hot glue, using some alcohol is a really good bet. Okay, looking good. Oh yeah, that is also connected on the top side here. And the other one probably is as well. So maybe we are just going to do the same trick over and over again. So I'm basically just doing the same thing again. I didn't rip the pads on this one. So we can put that one back, I guess. Okay, let's try that again, shall we? So some desoldering, some resoldering later. Let's see if this actually changed anything. Nope, still the same. Yeah, there's one capacitor left that I need to try. That's that one there, I think. And if that doesn't work, I'm not sure what I'm going to do. There we go. Yeah, this is also connected on both sides. Yeah, that's also good. So, yeah, no dice. Don't know what else could be wrong with this. Okay, let's see if that did something, anything maybe? That's the physical things that I could think of. Okay, another day, another try. Nope, exactly the same. It is exactly the same, more or less. We get fan spin for a second and then it just powers down. So it seems to be somewhat working. The fan doesn't spin up if it gets lower than, let's say, 5 volts or so. So it's a 12-volt fan. It should have some voltage at least outputting for a short moment, but then it just stops. And that's probably the safety mechanism in the power supply that shuts it down. So something is coming through to the output, so it's unlikely to be a connection problem, I think. Yeah, as I said, I don't know enough about these switching power supplies to really do anything useful here, I guess, except for measuring connections and some diodes and stuff, but it's not too much I can do, I'm afraid. It isn't completely shorted. There's no super bad solder joints that I could see. Difficult. Massive shout out, by the way, to Stefan, who runs the YouTube channel Pointercrash, who is working on an A3000T basically simultaneously to what I do here. I think he's a bit further down the road, and his A3000T is already reassembled and things. But he sent me an email, which I probably didn't answer a while back, with some tips regarding the power supply. And he made a video about recapping the power supply that I watched, and that was kind of invaluable regarding some stuff. So thank you for that, and check out his German language channel.
The next day.
So it's the next day. I got really frustrated with this thing, and I wasn't able to figure out the fault, and I started poking around off camera, and now I actually have it running again. So let me show you what I figured out. So I have my multimeter hooked up to one of the hard disk drive connectors here, and I'm going to show you the progress I made and tell you what it actually was in a second. So let me just show you that this now powers on. And the fan actually keeps spinning now, and we get a relatively stable 5.1314 volts on the 5 volt output. This is without a load, but the 5 volt rail is regulated nicely without a load even. So that is working again, I think. I think it's fully working again. You are probably not going to believe what it was. I was super stumped with this because I double checked everything, all the capacitors. I desoldered and resoldered several more and checked the polarities again from my pictures, checked the values of the capacitors. It all seemed really good. Continuity was there for all the pads and things. And then I started cleaning it some more and wiggling some components and things. And then kind of late last night, I adjusted this little variable resistor here, which is for setting the voltage on the 5 volt rail. I think it's to accommodate for cable losses and resistances and things like that, to have the 5 volt be spot on in any case. And when I did that, the thing sprung to life. So I think what happened is that while vacuum cleaning this, I must have somehow got some dirt in there that probably made the voltage fluctuate way too much, and the thing just went into shutdown, because the 5 volt rail is the rail that is monitored here, basically. That's the main rail, and that forced this into shutdown. Everything else I did was alright, I guess. So yeah, keep that in mind. I now cleaned it with some compressed air and put some contact cleaner in it, wiggled the contact around a few times, put some more contact cleaner in it, and it seems to be working stable now, thankfully. So, and of course we're going to have to check the other voltage rails before I do anything else. And then hopefully everything is kind of alright with this. We're going to see. Thankfully we have the color codes listed on our sticker. It's not recommended to run this without a load for longer periods of time, but I'm just going to do a quick check here. So let's see what we get. So this should be 5 volts, which it is. This should be our 12 volts, which is a bit low, but I think that's okay. We have our -5 on the white pin. That is pretty much spot on. We have our -12 on the red pin. That is very low, but it might just be regulated down without a load. So, and then we have a green wire somewhere. That should be high, actually, a logic high. That's power good, I think. That's what PG stands for. Brown wire is our tick signal. That seems to be fluctuating nicely. Yeah, so the 12 volt rail still seems a bit off, but maybe that's going to be all right in case we hook something up to it. Probably going to clean this up a bit more, put some more hot glue in there, some new hot glue to stabilize the capacitors that I removed the hot glue from. And then we're going to hook it up to the main board and see what the voltages actually look like in real life, basically. This is some circuit board cleaner, dedicated circuit board cleaner. It works really well for removing solder residue, flux residue rather. Let's see if we can actually power the Amiga with this. There should be no overvoltage. We're getting a white screen now. Oh, there we are. Yay! We are powering the Amiga still. Okay, let's check some voltages really quick before I put this back into its housing. That's 5.02 under load on the 5 volt rail. That is very good. Okay. That is our other 5 volt rail, 5.07, even better. That is our 12 volt rail. That's 11.6, that's good. That's our power good signal. What else do we have? The negative voltages. What's that one? That's -5. It's really difficult to get a connection in this connector. That's a -12. Okay. That is our tick signal. That's our -5. Yeah, that's very much spot on. Very nice. Okay, good voltages. So we can actually put this back in its casing. That's very good. Whew. I think the voltages are more spot on than they ever were, probably. Whew, that's a relief. Okay, cut to reassembly for the 100th time. No, it's just the second time, but it feels like a million years have passed. I'm going to put a little hint in the lid here for future generations or future me. Okay, time to close it up. So we can close it up the exact way it was. Just imagine having to put this together in the factory. I mean, they didn't make many of these Amigas, but wow, bit of a nightmare. So thank you on behalf of all the retro computer people for doing all the work back then in Taiwan. Whoever assembled this. Yay! Okay, and it also still powers up. And we have a nice airflow, which is actually sucking air in here. The air is blowing over this thing. Usually in newer power supplies you would have the fan on the other end, so you would have an opening on this side or on top and the fan directly on the opening that blows the air out. This one sucks air in and blows out air on the other end where those fins are. But yeah, probably the same airflow wise. I might put a better fan in here at some point. It's not very noisy. It's surprisingly quiet for a fan that is that old and probably hasn't been lubricated and things. Actually very pleasant, silent fan. So yeah, that worked. Let's do some tests on the mainboard, I guess. Wildly inappropriate setup for this, but I want to run some tests on this before I start recapping the board. So yeah, I basically have the power switch hooked up, the little connector for the LEDs and the key lock. I have the keys, I have a mouse hooked up here, no keyboard yet because lack of space. I have the disk drive hooked up with the Amiga test kit disk in there, so we are probably going to see whether the drive works if we get mouse input. That is going to require the key, I think. So let's put the key in here. Okay, got two keys. So maybe we're going to see the LED light up as well for the first time in history. At least having this in my possession here. So let's focus on the LED, I guess, which is going to be a bit difficult. Yeah, let's see if the power LED lights up. Yay! And it's dim, and then, yeah, just like on any other Amiga, basically. And the disk drive is also working! It just booted into Amiga Test Kit, which is a known good disk. So let's try that again. Takes a while because it's looking for a hard disk, I think. LED on the disk drive works. Mouse works! Yay! Okay, let's run some tests. 18 megabytes total memory, 2 megabytes chip RAM, 60 megabytes fast RAM. Nice! Let's see, I'm going to run the memory test. The mouse seems to work nicely. And it doesn't work without the key. So the key locks the mouse and the keyboard. Yeah, this is going to take a while. It's a lot of memory for an Amiga. But so far, so good. I'm going to report back after a while of running this. Okay, good news. We're on round 2. It passed the first round, which I guess means that the memory is alright. I would still have to run this for some longer to determine everything is alright in the longer term. But yeah, I'm happy with that. Keyboard, we don't have that. Floppy drive, let's see. It doesn't recognize the floppy disk. It sees a Go tag basically, but the floppy disk drive is reading. So I'm just going to do very basic testing on the floppy disk drive because we're going to have to look at that in more detail anyway. So yeah, it seems to be good. Even sitting on the power supply, which is of course not ideal. It's a magnetic device. Okay, can't read track 153, but it seems to be indeed a high density drive. Nice. Okay, what else? CAA, let's check the CAA stuff. Okay, that's okay. The clock chip is detected. It's of course not showing the correct time because it doesn't have a battery anymore, as you've seen in previous episodes. So it can't keep the time. Yeah, that's pretty good. Let's test the audio. I'm going to have to turn on my amplifier. Okay, we don't get anything on the right channel. Okay, that is interesting. So we get a signal on the left channel. but we don't get the right channel if the low pass filter is on. So I turn this on and the right channel dies. I turn this off and the right channel works. That is strange behavior. We're going to have to look into that, I guess. So right channel, I'm going to make a note of that, and that's going to be some more advanced troubleshooting. Yeah, serial ports, stuff like that we can't really check. It's with the video, that's a very basic check on this one. This is an old version of the Amiga test kit as well. It's gotten a bit more sophisticated. Everything seems to work. I was mostly worried about the memory, but that seems to be all recognized. 16 megabytes. And the disk drive also seems to work. Strangely enough, the audio. But we're going to look into that. Maybe there's a bad capacitor somewhere or something like that. I think it's the same audio circuit that all the other Amigas have, basically. So that should be relatively easy to understand, hopefully, for me. Yeah, and of course we can't really end this test without at least trying to start Tarikin. Okay, I think the disk drive probably needs a bit of a makeover. Okay, both channels work now. Of course, this is not the machine to play Tarikin on, really, but yeah, why not? Oh, and it crashed. I think that's probably due to the badly cracked version of Tarikin I have. I think my disk drive has some issues, actually. Yeah, something is a bit flaky with this still. Not sure what. But I suppose it's probably the disk drive. Software failure. Yeah, we need to do a lot more work on this, of course. I think I'm going to have to end this episode here. Thank you very much for your time. I am going to have to do some more work on the circuit board itself. Let's turn this off. It's pretty noisy. Still, so I need a new fan eventually, probably. Yeah, Amiga seems to be doing quite well. Memory tested good. The test kit worked, except for the sound. The disk drive seems to be a bit unreliable, but that's no wonder. I didn't do anything to that yet, and usually these need a bit of lubrication and cleaning, and maybe some adjustments before they work fully again. Yeah, the sound thing is a strange issue. We're going to have to look into that. Maybe the filter circuit is broken in some way. Maybe something else is broken. We're going to look into that in the next episode, which is going to be probably recapping the mainboard. And we are going to have to do a lot more work on the case and on other things, disk drive, hard disks, the expansion boards. This series is going to go on for a while. So I hope you enjoy this, and I'm going to do videos in between of other stuff, of course, because this is going to take a while. Thank you very much for your time. Hope you enjoyed this. Thanks for watching. Special thanks, as always, to everybody who supports me on Patreon and on Ko-fi and on the YouTube channel memberships page and elsewhere. The links to that are in the video description and on my website, which is also linked in the video description. So you should have plenty of options to give me some support in case you want to do that. You make these videos possible, so thank you very much. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye!